Hello. Today we're going to be talking about how to solve particle bunching in Godot. So basically, what particle bunching is when you have some particles that are emitting at some point that's moving, and they end up bunching together because of that. So in this example, we have some GPU particles attached to a node that is just going to be following the position of the mouse cursor, and it's emitting 50 particles. So let's take a look at what happens and we can see the issue. As I'm moving my cursor, they're following along, but as I start to move it faster, you can see that there's these kind of large gaps between the particles. And I move faster and faster, the gaps get larger and larger and larger and larger. And this might seem like a super easy fix. You want more particles, let's increase the amount of particles. So let's try that. We're going from 50 to 500. That is a 10x increase. However, you'll see that the issue persists. There's still these large gaps. We have 10 times the amount of particles, and there's still these huge, huge gaps. So if we want to make it so they're not bunching together like this, how can we do that? Well, let's define the issue. Basically, we have a position. We have some particles spawning at that position. The particles move. Some more particles get emitted. And they move again, some more particles get emitted. And basically the issue is that the particles are emitting at every frame where they are and totally ignoring the gaps between frames. They're positioned in between frames, so you're only emitting particles at these specific points, thus forming the clumps. So when we increase the number from 30 to 50, rather than having a ton more particles along the path, we just have, at the 2 points where they're already clumped, we just have larger clumps of particles. So the way that we want to fix that is we want to say, here's how much distance we've gone between the two frames, and rather than just spawning it where we are now and having spawned it where we were, we're going to spawn it along that path, along this distance. So that way, no matter how large this distance is, you're going to get some particles in there, and it won't clump up. So this is where our fix comes in. These are blue particles, and let's talk about what's different about them. So the first thing that I changed is this fixed FPS right here. So basically, what this does is its default is 30, and it is how fast the particles are processing, updating. So if you have a game that's running at 60 FPS and your fixed FPS is 30, like the default, every other frame the particles are going to be doing some processing. But if we increase it to 60, it's going to happen more often. And then those gaps that we talked about are going to be less frequent, so it's going to be less of an issue. However, this only works to a degree, right? Because you can't increase this to 5,000 because you can't have 5,000 frames per second. You can't do 5,000 calculations per second, at least on reasonable machines, right? So now we're going to address the issue of actually going back and calculating and filling in those gaps that are created. So the way that we're going to do that is we're going to be using shader materials, and then we're going to edit the shader script. So on some basic particles, you're going to go and you're going to make your particle process material like you normally do. And at the very end, you're just going to click on this little drop down here. Then you're going to hit convert to shader material. And once we do that, we can get the shader material, which is useful in a couple ways. It allows us to access this shader right here, which is what we're going to modify. Now, I would highly recommend that you make this change after you've done everything else, because you can still edit stuff through the shader parameters, but it's a little less hard. Everything's not in menus, and there's a couple things that are just don't show up here. And also, if before you convert it to this shader material, you have any gradients or anything, you're just going to need to go back and redo those. It's not a huge deal. Okay, so now that we've done that, what we're going to want to do is we're going to want to go into the shader, just click it, it'll open up down here, and we're going to make some changes. This is a version where I already have the changes, so I'm just going to be highlighting stuff and pointing stuff out. Almost everything here is just the basic stuff that shows up, and this is just the conversion of all of Godot's code for spawning in the particles. So I've done two changes. First, up here, I have in two new variables, spawn p1 and spawn p2. And basically, this is going to be the 2 points that we want to draw the line between. And this point's going to be where we were. This point's going to be where we are. And we're just going to use these points in our calculations to spawn in particles in between. If you're totally new to shader code, uniform is just like export, but in shaders. Vector3 is just the type. Then we have the name followed by a semicolon for syntax. And then we want to find here the function that is spawning in the particles or defining the position that they're spawning in. So I'm going to hit it with a Control F and look up pause. And we can find this calculate initial position function. Yours will not look like mine. Mine is modified. What yours will look like is, this is just the default one I have up. It will look something like this. And you just want to delete all that and replace it with this fix I have, which is this. So this is just basically, given these 2 points we already defined earlier, it's picking a random point in between them. Getting into the math very, very briefly, we're just calculating the total distance between them, and then applying that to, or adding that to position 1, and then multiplying that total distance by some random number between 0 and 1. So you're either 0% of the way between particle or point 1 and point 2, or 50%, or 20%, or 30, or 100, which gives you essentially a random point along those 2 points. And we can see that this is working because if I scroll down to, in my shader parameters, right here in my shader parameters, if I scroll down, you can see our spawn P1 and spawn P2, which we added. And then if I change this, let's say I make this 100, you can see it's now spawning along that line. And if I make this 100, it's spawning along that line. So we're almost there. Now all we want to do is every frame basically say, hey, I want spawn P1 to be where we were. I want spawn P2 to be where we are. That way we're drawing that line and filling everything in, and it's great. So let's go into the script and see how we can do that. So there's a couple different parts to this. First, we're just getting the last mouse position and the mouse position. And then at the end of every iteration of process, we are updating the last mouse position to mouse position. So that way it's always what it was. And then we're calculating exactly what values we want P1 and P2 to be, which are just our last mouse position and our mouse position. But I'm putting them in a vector3 because that is the data type that the particles want to work with. And then I am using process material.set shader parameter, to put it in there. So this is, I'm just directly calling it because this script is attached to the GPU particles. But of course, if this script was not attached, you'd want to somehow reference the GPU particles, then write the dot process material dot yada yada yada. And then, so other than that, line by line, these are going to stay pretty much the same. This string is the name of the variable you want to change. So in this case, in our case, it's just P1 and P2. And then this is the value you want to put in there, which we're calculating up here. So that is going to be a fix. And we can see it working right now if I run it. And now both particles are visible, so you can compare. Remember, the green is our old one that we didn't make any changes to, and the blue one, we went back and made those changes. And you can see when I move it, especially when I go faster, the green is bunching up, and the blue is forming a pretty nice continuous path that is not bunching up in those big clumps. And also something to note about the blue is because it's randomly placing them along that path, it will actually get more filled in if we have a higher amount. So for example, we had 500. If I increase that to, let's say, 2,000, and I run it, you're going to see that it does actually fill it in and make it smoother and more filled in. All right. I hope this was helpful. Bye.